Thank you very much. Good afternoon, everybody. Thank you very much for staying late for this last session. You know, I was thinking about starting by saying we saved the best for the end, but I'm too modest to say that, so I won't say it, right? So I'll just jump right into the session. This is supposed to be a presentation by 3 speakers, as you can see. Unfortunately, 2 of my colleagues could not make it because of the obvious travel issues. So Eric from EPFL and Mehdi from Juniper, they are also part of the presentation, and I've got their videos with me that I will play for you. Both Eric and Mehdi, I believe, are connected to us virtually, and they will be answering any question that you may have. So just to give you some perspective, just context of this presentation, EPFL is a university, and we'll talk about it a little bit more. Eric is going to talk about it. EPFL are deploying, in the middle of their deployment of SONiC. They are deploying around 250 switches running SONiC. They're Dell switches based on Broadcom silicon. EPFL has chosen Apstra AOS as their orchestration platform. EPFL has already devised, tested, and validated a migration strategy. And both Mehdi and I worked with them in validating and testing this strategy, and that's how I am here. So in terms of agenda, we'll start by Eric's presentation, who will give you an introduction of EPFL. He'll also touch upon the current network architecture, but more importantly, what are their goals with the new data center fabric, and why, as an enterprise customer, they chose to adopt SONiC. I will then take over and I will talk about what does the new fabric architecture look like. I'll talk about the migration strategy, how EPFL can migrate their virtual machines from their legacy data center to their new SONiC fabric. And then Mehdi from Juniper Apstra will talk about their approach to automation, IBN, and how it can help in migration for a large-scale deployment. So this is going to be the flow of the presentation. Let me start by playing Eric's presentation.
Hi, my name is Eric Recci. I'm working at EPFL in Switzerland as an Is
the video showing on your screen? Yes. All right, there we go. It's a second screen.
Structure architect.
That's troubleshooting.
There for the last 14 years.
I'll play it from the beginning, no worries.
So let me do a small introduction about the EPFL. So the EPFL is a higher technical school. We have a little less than 12,000 students, of whom 2,000 a little bit more than 2,000 are PhDs. We have added to that a little bit more than 6,000 staff members. So the EPFL, you find 5 different schools, 2 colleges, 20 institutes, 44 research centers, and a little bit less than 400 different laboratories. The 3 main missions of the EPFL are, of course, the education, but also the research and the innovation. Now, let's go back in today's presentation topic. So this is a, let's say, high-level schema of our actual network architecture. You will notice on the red square the portion that is used for the data center itself. So I will not speak more about that because it will be just what we have, but it's also what's interesting where we want to go. So regarding where we want to go, these are the goals for our new data center network. So we wanted to have no more blocking links for redundancy, meaning get rid of the spanning tree. Also, we wanted to be able to physically place a server everywhere within a pod. So a pod is a group of 16 racks where you will have the same spine leaf connectivity. We will connect different pods through a superspine. So the connectivity between the spine and the superspine will be done through 400 gig links. The idea here is to be able, to really do some smart placement with the host. So within the pod, you can place hosts based on their power consumption, their weight, or their heat. Like that, it's not, you are going to fill the first track, then you go to the next one, and so on and so on. Because we had in the past, we weren't able, for instance, to add more than, I don't know, 15 hosts within the same rack because, they were consuming too much energy and so on. So with this approach, we will be able, to optimize the placement and to gain in terms of capacity ratio. Also, we wanted to have the ease to add links, meaning to be able to add bandwidth. That was very important for us. Other point was the flexibility for host connectivity. So within the pod, you can connect hosts that have ports from 10 to 100 gigs in the same switches. The last one is also to be able to provide hardware as a service capabilities with dynamic network and security assignment through automation. So here, the automation is a really, really important part for us. It's part of our self-service portal that we are offering hardware as a service for the entire EPFL. Now, why SONiC? So we wanted the same network operating system, meaning so the functionality, reliability that come with across different hardware vendors. We wanted to avoid being, locked with one single vendor, hardware and software, to be able to freely choose the best hardware that suits our needs. That's the goal with that. You can have, so we want mixed within a pod different hardware vendor for switches, but between pods, we will be able totally to take different hardware vendors. For instance, pod 1 will have hardware vendor 1, and pod 2 might have hardware vendor 2. But that doesn't really matter because across all of those hardware switches, we will have the same network operating system, then the same operational model. Of course, being able to separate the hardware and the software, it's very important for us. We are doing this abstraction on other technical domains, and we brought that to the network part of it. Advanced telemetry, very, very important for us to have a good understanding of what's happening in the fabric, to help us, predict things or do rapid troubleshootings in terms of issue or performance issue. Depends, it can be a failure or performance degradation. So on both cases, telemetry is very important for us. And of course, SONiC is a modern network operating system, right? That is able to answer our needs in the dissimilar workloads that we will have. And it's also a network operating system that is able to evolve accordingly with the best standards. So today we have seen that a lot of enterprise customers are gaining a lot of interest in SONiC and the value it can bring to them. Right. Thank you very much.
Okay. All right. Thank you, Eric. So this is the new fabric architecture for EPFL. As you can see, it comprises 3 data centers. The 2 top data centers, INJ and MA, they are their existing, or may I say, legacy data centers. This DC 2020 in the middle, that is the new data center they built. Their initial deployment will comprise 4 pods, 2 pods in the new data center, and 1 pod each in their existing data centers. You can see that each data center has a border pod. And these border pods connect different data centers together. There is a full mesh in these border pods. At this time, EPFL are starting with 2 times 100 gig connections between each border leaf, which means that they will have 400 gig between data centers. But mind you, all of these border leaves, they are Trident 4 based switches. They all support 400 gig. So in future, EPFL, if they choose to, they can upgrade it to 1600 gig. But at the time, they're very happy with this because currently their data center interconnect is 80 gig. So they're already upgrading from 80 gig to 400 gig, which will be sufficient for them for some time. If I double click on the DC 2020, you can see that each pod comprises 4 spine and 32 leaf switches. The connectivity between the leaf switches and spine switches at the moment is 100 gig. The leaf switches, they're all MC-lag pairs. So they use MC-lag and logical VTAP connectivity. Spines connect to super spines, which then super spines connect them to the border pod. All connectivity with the super spine is 400 gig. The connectivity with the legacy network was an interesting design question. So we had a discussion. Now, there were 2 options, right? One option was that EPFL could connect legacy network to the SONiC fabric in each data center. So they could have 3 type connection going into legacy, or they could just connect from 1. Now, if you connect from 3, obviously you have more redundancy. But then, because they are going to extend VLANs between their existing with legacy data center and the new fabric, they would end up in a looped topology. So the mantra from EPFL has been, take the complexity out, make the network simple. So they said, we're only going to connect it from 1 data center. So legacy network is only connected to the new SONiC fabric in 1 data center. So there is no concept of loop at all. Now, in terms of migration, we sat with their team, the network architect, Julian, and Eric, the infrastructure architect, and we said, okay, what are your requirements from it? First thing they want is, they want a phased approach. They do not want a big bang for the migration. They have a large virtualized environment, and they want to leverage vMotion for their virtual machines when they are moving them across from the legacy network to the new data center. As you know, I'm sure everybody in this room has experience of migrations. When we do these type of migrations, there will be some outage. So my next question was, how much outage you can bear? And the answer was, up to 1 minute outage is okay. If it's more than 1 minute, our business is not going to accept it. So stringent requirement on that as well. This is the migration topology looks like. As you can see, there is layer 3 connectivity and layer 2 connectivity between the legacy and the new fabric. Layer 2, why? For the extension of the VLANs, because that is how we can do vMotion. Layer 3 connectivity for the BGP pairing. When we look at the migration strategy in detail, this is how it works. So, for example, when you want to migrate, say, 1 VLAN, let me call it VLAN 10, from legacy network to your new SONiC fabric, the process would be, you will extend this VLAN to the new fabric. So how you do that, you obviously allow it on the trunk links, on the layer 2 connection, and then you also create that VLAN in your new SONiC fabric. So obviously there will be a VNI, et cetera, assigned to it. Imagine that you have done that process is done, and you can see there is, I'm showing 1 hypervisor, 1 server in the new SONiC fabric. Say that server now is in VLAN 10. The next step would be that you can, because the layer 2 extension is there, now you can migrate your virtual machine from your legacy network to your new SONiC fabric on this hypervisor. How much outage we should expect in this process? Answer is 0, no outage. And that's what we validated. It works well, no problem there. But there is one issue there. What is that? Where is the default gateway at the moment? Default gateway is still in the legacy network, which means that there is a chance of some tromboning, right? Because imagine that your new virtual machine sitting in this new data center, it needs to talk to another host, which is also in new data center. So maybe on the same switch, but in a different subnet. What will be the traffic flow? The traffic will flow from this virtual machine, will go all the way back to legacy network, will get routed and come back. So there will be some tromboning at the beginning, but that's okay because it's just a transition phase. Once the EPFL decision was, once they have migrated 50% of hosts or virtual machines within a VLAN, that is the threshold for them to migrate the default gateway, to bring the routing in the new SONiC fabric. And once that is done, and we did all that validation, once that is done, then they will proceed with the default gateway migration. So how do you do that? Very simple. What they're going to do is, what we did in the validation, we would create the same default gateway IP as an Anycast gateway in SONiC. We would shut down the sub interface in the legacy network. So in the legacy network, they have a switch where they have a sub interface which is acting as the default gateway, the IP there. Will shut down that sub interface. As soon as you shut down the sub interface, BGP will stop advertising that subnet from legacy network. And at that point, you very quickly start advertising this network from the SONiC fabric. So you're doing these 3 steps, and you're doing it very quickly. And you do it properly, you do it in a managed way, in a proper way, the migration happens very quickly. Anybody want to go for a wild guess how long it will take? Obviously, there is protocol convergence happening there, right? Because now BGP is not advertising this subnet from legacy network anymore. This network is being advertised now from the new SONiC fabric. So convergence is happening. Any guess how long will be the outage? 5 seconds, 10 seconds, 15 seconds? It was better than we expected, right? Sorry, you said something, Uma?
Oh, no, I was just asking, just wondering how far apart are the data centers?
They are close. They are within, they are within a mile.
There's the vMotion migration restriction. So it's within a vMotion area that they can do that. Okay.
Correct, yeah. So what we saw, that the result was really good, right? We saw the maximum outage we saw was 6-second outage, and that was for the host or virtual machine which remained in the legacy network. So now default gateway is in the new SONiC fabric, and this host which saw 6-second outage, it remains in the legacy network, so that was the outage. But for the hosts which are in the new SONiC fabric already, they only saw 1-second outage. So the result was really, really good. Better than what we were expecting. But this is the strategy if you want to adopt. You can do it manually, and Julian did a very good job here from EPFL, but this works well for few VLANs, if you've got a bunch of VLANs. EPFL have got thousands of VLANs. So the next step was, okay, we understand this, we validated this methodology, now we want to do it via automation. We want to leverage our orchestration solution. And their expectations were 3. Their expectation was that first they wanted to have the ability to stage all the change before the change window. They can have all the configuration, all the objects, new VLANs, etc., ready and prepared in their single source of truth, in their orchestration platform. So that was their first requirement. Second requirement was they wanted a feedback loop. They wanted to understand that when they do the migration, actually it is, according to the expectation, everything is okay? Kind of the post change test. I mean, people who have gray hairs as much as I have, you remember we used to create pre-change sheet and post-change test spreadsheets, right? So those type of things. They wanted a feedback loop where they could quickly check, not by manually, not by Excel sheet, with their automation. They can quickly check, have a feedback loop to see that the change has been successful. The number of routes they were expecting are still there, right? The number of MAC addresses they were used to learn, everything is there as they expected. But if it doesn't go according to plan, they want to have the capability to move back to a known good state with a push of a button. So they want to back out the change from those hundreds of leaves with a push of a button. Can their automation do this? And that's where Mehdi and the Juniper Apstra team came in and they showed their capabilities. Let me play Mehdi's video. This is the last part of my presentation. You really liked this sentence, didn't you? Okay, there we go.
All right, hello everyone. This is Mehdi Abdulwahab. I am last in this 3 parts presentation. Hopefully you enjoyed the 2 previous ones. For the quick intro, I work at Juniper as a product manager on Apstra. Before I go into the context of EPFL's migration and how we did achieve the requirement, how we did satisfy the requirement mentioned by Kamran, I'm going to first give you a high-level overview of some of the guiding principles we have been following when building the product. So we have been using these terms early on of intent-based networking to describe our approach. And what we mean by that is that we are decomposing the notion of automation into 3 main dimensions. The first one is the need to automate user input. And that's key. Like, you want to make sure that you have all the required variables provided in the right format, making sense both individually as a configuration variable and collectively, so that you have no conflict or no duplicate between those variables. This is an automatic check that the software has to perform, and it's important to be performed before you embark on any configuration generation. Now comes the second dimension, which is actually the configuration generation or called configuration rendering in automation terms. That's the most widely known dimension of automation, even though not the most complex one. So you, of course, need to know various vendors' APIs, semantics, and how to get the right sequence, of course, to get to a specific outcome. But that's just one aspect in the overall journey. And the last dimension, and not the least, is really our end goal here, which is the validation step, automating the network validation. And by that, I mean comparing the actual states, operational states on the network to the desired state you have for that network. And this is really what operation teams are looking for, because they do care about this operational outcomes. So the 2 first steps are important, but the last one is what we strive for, so that you can get the high-level vision of what we're looking for. Now, in the context of EPFL, the first step we had to go through after standing up the physical fabric is pre-provisioning the required EVPN tenants and virtual network. So this is just a screen capture that shows you on the left side the user input, which is really minimal in terms of typical tenants and VLANs you want to pre-provision on those tenants, and on the right side the actual outcome or the summary of those pre-provisioning. So that's really the first step. And then quickly after that, you want to basically specify or express membership of specific servers to those virtual networks, right? So for that, you want a solution that allows you to leverage a rich data model from design, where you have labeled your racks and your servers in a specific schema. These are just generic labels that I'm using here, of course, but you may want to use a specific labeling schema for every part of your infrastructure, so that you can very easily express membership of servers just by leveraging those labels. And then we push it further by, in the case of EPFL, we have been using tags applied on servers. You can think of them as metadata. And we use those tags to color code the servers as in what type of applications are meant to be hosted on those servers, right? So this is just based on any customer environment. And the goal here is to leverage those tags to do batch assignment at scale of server membership, saying any server with that tag in that pod, I want to include it in this virtual network, or any kind of condition like that. So the goal is to really industrialize membership of your VLAN assignment, especially at migration time, where you have a very, very large number of VLANs and servers to pre-provision. And of course, right after the commit push of that intent, you have the configuration that is pushed on the device. And what you want from the system is to actually have a validation of that state. What you see here is an example that I have picked of one of the EVPN states to validate, because that's one of the complex networking protocol out there. It has multiple routes that are propagated, and when you enable a layer 2 virtual networks like we did, you have one important EVPN route type that is sent, which is EVPN route type 3, right? This is what creates the broadcast domain within the virtual network, and it has its own, parameters and complexity. So in this case, you see the system, which basically has an expectation of 108, routes in this case, and it will automatically tell you the presence and absence of those routes. In this case, we are basically missing 102 routes. I had to take the screen captures very quickly right after the commit, because this is just the protocol convergence times, but then right after a few seconds, this gauge goes down. But at least it shows the principle of having the need to automate this validation at scale, because at the end, you end up in a very, very large number, much more than that, and you cannot cope with just doing that manually via the CLI and having to know all the context of the configurations. Of course, you want to deep dive, and should you have any consistent anomalies, you want to double click on them and want to know on a specific virtual networks what routes are missing, so that you get an idea of the scope of the issue. So in this case, this is really showing the detail of the routes where they are missing on a per VNI basis and on a per device basis. And then the third step in the migration is that once we get this 50% of servers being migrated to the new network, we had to basically promote virtual networks from layer 2 to layer 3, so that we can move the default gateway up to the new infrastructure. And this is shown here on the left with very easy day 2 addition of this virtual network to, as I said, promote it to layer 3 with the layer 2 information. And then you see, of course, incremental configuration being pushed to the device using, in this case, the SONiC API, which is a RESTconf API exposed by the switch that we consume as an automation solution to make granular incremental changes which will not disrupt the rest of the configuration. And of course, this new intent generates new EVPN routes. So you want to have new data collection or new state collection being performed automatically. These route types have different semantics than the previous ones because they deal with VXLAN routing instead of VXLAN bridging. So you don't want to basically, again, manually validate that. You just let the software collect the data and generate expectations and compare those expectations automatically to get a sense of how the network is operating. And then finally, any migration with all the precautions you have, you want to account for a contingency plan. In this case, what it means for us is the ability to give to the user the ability to roll back the entire network to a previous state, not just a given switch rollback, but a system-wide or fabric-wide rollback, so that you can very quickly, with no stress, roll back for any reasons being related to the network or any external reason. That's the end of my presentation. Thanks for listening.
Thank you, Mehdi. So the message from EPFL is that SONiC is ready for enterprise deployment. They also wanted to highlight to the community that at this point, in their view, there is no viable, suitable orchestration option in the open source community, in the SONiC community. So that is a call out to the community that we need more automation and orchestration solutions. I think Lumir and AT&T team showed us a way through Lighty, and I'm sure community can look at other ways as well, but definitely customers are looking for these type of solution, and Apstra is providing that solution at the moment. There's a link in the presentation where you can download, you have access to a lab where you can play around with SONiC and Apstra so you can understand how this integration works. And finally, you can look at my YouTube channel, Love to Network, where I have some how-to videos on SONiC. There I'm also going to upload a video which will show this migration strategy that I talked about. So thank you very much for your time. Back to you all.
Any questions? I had a quick question. Just that that whole migration that was going from the legacy to, you mentioned the outage times, but how long did it did everything take to get over? Like in 6 seconds, everything moved over from one data center to the other, or did it take longer than that? Like you said, a 6 second outage, but I didn't know if that was all the migrations had moved, all the VMs and everything had moved, and you could sort of shut down the old data center.
Sure. So it's the phased migration, right? So what they do, Umar, is they migrate some bunch of VMs. There is no outage during the VM migration. Once they have significant number of VMs within the VLAN migrated to the new fabric, the key thing is the default gateway migration.
Switch, yeah.
And that is where where we see the outage. I think overall their plan is to do this migration over a few weeks.
I see. Okay. Makes sense. Yeah, you're trying to stage it and see how it works and all. Great.
Perfect.
Thank you very much.
All right. Thank you very much.
All right. So